Good morning, children. Today we are taking up what are the basic properties of charges. So look, first property that we are discussing, charge is the characteristic property of mass. What does it mean? It simply means that a charge is a guarantee that a body will have mass. Say for example, electrons and protons are having charge. So definitely it will have some mass. But opposite is not true. Neutron has mass, but it does not have any charge value. So that's a statement taken. Charge is the characteristic property of mass, but mass is not a characteristic property of charge. So that's what I discussed here. Charge is the characteristic property. Charge is the characteristic property of mass, but any object which has charge will essentially have mass. Charge is a guarantee of having mass. Like electrons and protons has charge, so essentially it has mass, but opposite is not true. Opposite is not true. Neutrons have mass, but it does not carry any charge. That's what mass is not a characteristic property of charge. So it is the first property of charge. Next, charge is always additive in nature. It follows what? Additive property. What is this additive property? It means what? Total charge possessed by a body is algebraic sum of all the charges given to the body. Say for example, if a body is given some charge, say q1, then q2, then q3 and so on, then qn, then total charge will be what? Algebraic sum of all these charges. Say for example, two bodies are there. First body is having say charge plus q, another body has charge minus q. So total charge is equal to what? Plus q plus minus q. That is what it is, the total zero charge. Now the next property. This is what? Relativistic property of charge. Now before we proceed further, let me just bring a background information. The mass of a particle increases with increase of speed. And what is the relation? This relation is given this way. It is what? It is Einstein's mass energy this relativistic mass equation, mv equal to m naught upon under root 1 minus v square upon c square. And what is the formulation on it? mv is what? It is dynamic mass. M naught is what? Rest mass. V is what? Velocity of object. And c is what? It is velocity of light. Now in case v equal to c, then v square will be equal to c square. Now if it is, because it is approximately equal, the particle starts moving so high that it becomes numerically equal to the velocity of light, then v becomes equal to c, and so this particular term will become what? 1. So in denominator it will be under root 1 minus 1. 1 minus 1 is what? Something upon 0. Something upon 0 means what? Mass will tend infinitely large. So that's what a statement is taken. Mass of a body, mass of a particle increases with increase of speed, but the magnitude of the charge remains unaffected by motion. That's what a relativistic property of charge. The charge is unaffected by motion. That is, whatever is the magnitude of the charge at rest, the same it will continue even if it is moving. Okay. Now coming next property, conservative property of charge. So this statement is delivered in two fragments. Two different ways are there, and both ways I am telling. The charge cannot be created, cannot be destroyed. Only it can be transferred from one body to another body. Okay, it can be only transferred from one body to another body. Let us first understand it in this context. In triboelectric series portion, we have seen that when are we trying to generate charging by friction, so glass rod has got some positive charge, and this positive charge has been obtained when it was rubbed with silk cloth. So look, the series FG wala pacer, it stands that glass is higher up in the series, silk is down in the same series. So glass has obtained positive charge, silk has obtained negative charge. Now in case you add up total charge, so total charge is coming equal to 0. Look, charges cannot be created, cannot be destroyed. So total positive charge which is being generated on the glass rod, it is it is equal and opposite to total charge that is developed, negative charge on the silk cloth. Okay, so it has not been created, the positive charge has not been created on the glass rod, it has been simply transferred from glass to the silk cloth. It is what it is, the first statement. Now coming back to the second statement. Second portion of the statement is taken this way. Look here, I am taking the total charge of an isolated system remains conserved. Now I am arguing this way, by glass rod पे positive charge generate तो हो गया. How can you say the total charge of an isolated system remains conserved? तो कैसे conserved? Glass was not initially having any charge, now it is having. So again, the problem in this statement is what you are considering glass alone as a system, but glass alone is not a system. Glass plus silk taken together is what a system, and total charge of an isolated system remains conserved, and that's what the total charge is, what it is, 0. Okay, that's what explanation of both the statements. Now another example we are taking, it is regarding the pair production and pair annihilation. So first, again a background information is there. So this explanation is coming in light of what? Antiparticles. Electrons and positrons are what? Antiparticles. Now what are antiparticles? Antiparticles are those particles having same mass value and same opposite charge value, equal magnitude of charge but just opposite in nature. Say for example, if I am talking electron and proton, they have got equal and opposite value of charge, but proton is heavier, so they are not antiparticle. If I am talking for electron and positron, so electron and positron not only have their charge value same, but their mass value is also same. Electron is negatively charged, positron is positively charged. Now when such antiparticles come in contact, they annihilate their mass into the energy as per relation equal to mc square. Now that's what the equation starts. This is what one electron is and this is what one positron is. This electron is approaching towards the positron and positron is approaching towards electron. Okay, they are just approaching one another. So they will come in contact and they will execute what? They will execute the process of what? Pair annihilation. What will happen? They will generate two gamma rays photon, and these two gamma rays photons are just moving in opposite direction. These gamma rays photons are just moving in opposite direction. Now total linear momentum before collision, they are coming close to one another. It is equal to total linear momentum after collision, they are just receding away. Understood? Now let us understand, the electron and positron taken together constitutes a system. So it is what? Total charge is equal to what? Minus 1 unit charge of electron plus 1 unit of positron, the total charge is 0. Now these gamma ray photons are just electromagnetic wave. These are gamma rays photons, and the gamma ray is what? It is electromagnetic wave. EMW stands for what? Electromagnetic wave. These electromagnetic waves are chargeless, massless energy packets. So these photons are what? Separating apart this way. These are separating apart. So first thing. Now just opposite I will take up. There is another process which will take up the same thing in opposite light, and that's what? Pair production also. So if I talk about pair production, let us take up this process, this particular process, and what will happen? Just opposite to it, let these two gamma rays photon to come close to one another. What will happen? They will produce one electron and one positron. Electron will have total charge -1, positron is equal to +1, total charge 0 here, and because electromagnetic waves are what? Chargeless, massless energy packets, so it means that for total charge 0, total charge 0. It is also in follow-up of this principle of conservation of charge. Now let again just draw a simple conclusion. Let me just talk background first, so that even if you have not attended the previous lectures, you are able to go through it. Every atom has got some nucleus, and this nucleus is surrounded by what? These orbits. In these orbits electrons are orbiting, and the notion is, the main theme is, every atom is neutral. It has same number of electron and same number of protons, and this makes atom electrically neutral. Atoms are electrically neutral, but if some electrons and some positive charge that is possessed by the proton is not equal and opposite to the negative charge possessed by electron, then it becomes charged. If it is not equal, then how is it possible that let some electron to go from one atom to another atom? And how it will go? Only loosely bound electrons are transferred on rubbing from one surface to another. The body which loses electrons gets positively charged, and the other body which gains electrons acquires negative charge. Now this will lead to a particular property, that is what principle of quantization of charge. Look, it is suppose the first atom, it is suppose the second atom. Suppose the electrons on being rubbed are being transferred from here to here. Now suppose they are being transferred from here to here, then what will happen? Suppose first atom has delivered one electron, so it will obtain 1 + 1e charge positive, it will obtain -1e charge negative, it will obtain +2e charge positive, it will obtain -2e charge negative, it will obtain +3e charge positive, it will obtain -3e charge negative. Now if it has given up n electrons, it will obtain +ne charge and it will obtain -ne charge. E is what? Charge over the electron. N is what? Number of electron transferred. So that's what this statement is leading to, that total charge possessed by a body is integral multiple of fundamental charge. And fundamental charge is what? It is the minimum charge that can be produced on a body because of transfer of electron, and that is 1 electronic charge is equal to fundamental charge. Okay. Now that's again I will say, this is what this statement of law of quantization of charge. The total charge possessed by a body is integral multiple. N can be what? N can be 1, 2, 3, 4, etc. Okay, so total charge possessed by a body is integral multiple of fundamental charge, where fundamental charge is numerically equal to this much. So either the body will obtain positive charge, it will obtain negative charge. So one body will obtain positive, next body will obtain negative. If first body is losing 2 electrons, then second body will gain 2 electrons. If first body is losing 3 electrons, then second body will gain 3 electrons. But this is not possible. Half of the electron cannot be transferred, 3/4 of electron cannot be transferred. Similarly, just take that in case I'm asking a question, is it possible to generate 0.8 into 10 to the power minus 19 coulomb charge? So answer is no. Why no? You put this in this equation, Q equal to N into E. What is Q value? Q value is this much. What is N value? N value we'll calculate. What is E value? E value is this much. You will find that N value is not coming a whole number, and that's what the total charge possessed by a body is integral multiple of fundamental charge. Okay, now next question. Charge on one electron is this much, charge on proton is this much. Is it possible to generate this much value of charge? Again use the formula. Which formula? Q equal to N into E. Find the value of N. N comes equal to 3. It is a whole number, so yes, we can generate this value of charge. Next part, simple. On the property basis I am asking, whenever we are transferring the charge from one body to another body, like earlier glass rod was having positive charge, silk cloth was having negative charge. So because glass rod has given up some electrons are charged particles, so it will have mass. So because it has given up charge, so it has given up mass, so its mass will decrease. And silk has obtained some electrons, gained some electrons. So because electrons are charged particles, so it will gain some mass as well. So its mass will increase, its mass will decrease. So any body which has got positive charge will have its mass loss, and any body which has negative charge will have its slight mass increment.